You know, we see locks everywhere, on our doors, our phones, our bank accounts. But what about the unseen locks? The invisible tech that's standing guard over pretty much every piece of software we use. Today, we're gonna find the key.
I mean, you've been there, right? You install a new program, and before you can get started, it asks for a key, an activation code. Why? Well, the answer gets right to the heart of a huge dilemma for the entire software industry. Just imagine you've spent years of your life building an amazing application. The second you sell your first copy, it can be copied perfectly, endlessly, and then passed around for free. So how do you protect all that hard work? That's the developer's dilemma. And the solution is actually pretty clever. So the big idea here is to wrap the application in this protective layer, what we can call a digital security envelope. Now, this envelope doesn't change what the software does, but it completely controls how, when, and where it can be opened and used. This protection isn't just something that's tacked on at the end. It's actually baked right into the software's journey to your computer. So after an app is developed and built, you get to this crucial third step. It gets sealed inside that security envelope. Only then is it ready to be packaged up and sent out. And that very last step, activation, that's you, the user, getting the one-of-a-kind key to unlock that envelope for the very first time. All right, so what's actually inside this digital envelope? It's not just one lock. It's a whole series of sophisticated layers all working together. Let's peel it back and look at the 3 standard layers of protection that make up its core. First up is what's called wrapping. This is the outer shell. The protection code literally wraps itself around the application. So when you double-click that app's icon, you're not actually running the app directly. Nope, you're running the security wrapper first, and it decides if it's okay to launch the application hiding inside. Next up, we've got encryption. Okay, so if wrapping is the armored box, encryption is the scramble lock on that box. The application's actual code gets turned into complete, unreadable gibberish. Without the right key, which the security wrapper holds onto, the code is totally useless. And the third layer is this really clever defense mechanism. It's all about anti-reverse engineering. These are little traps and tricks embedded in the code to stop anyone from trying to deconstruct the program to see how it works. It's kind of like a security system that goes on high alert if it senses anyone trying to pick its locks. So these layers form a pretty tough defense, right? But how does all this connect back to that activation code we talked about at the start? Well, it all comes down to locking the software to a single computer, and that is the very heart of copy protection. The whole point is this: to stop one copy of an app from being installed on hundreds of different computers, the software needs a way to recognize and basically bind itself to one and only one machine. But how can a program recognize a computer? It does this by taking a unique fingerprint of your computer. Think of it like a digital detective. It scans your system's key components, the serial number of your CPU, the ID of your hard drive, your operating system, and it combines all those unique codes into a single rock-solid identifier for your specific machine. And that fingerprint is what kicks off what I like to call the activation dance. When you first run the program, it creates that unique site code. You send this code to the software company. Then, on their end, they generate a matching activation code, and that's the key that only works with your computer-specific fingerprint. You pop it in, and boom, the software unlocks. But if you try to install that same software on a friend's computer, it'll generate a totally different site code, and your old key just won't work. Okay, but that brings up a really good question, right? We all upgrade our computers. What happens if you swap out your hard drive? Does your expensive software just stop working? Well, luckily, developers have thought of this. While changing a key component can reset the license, they can set up a more flexible policy. This allows the software to tolerate a certain number of hardware changes. So swapping a hard drive might be okay, but maybe changing the motherboard, CPU, and the hard drive all at once would be too much, and it would probably ask for a new activation. But here's the thing, modern software protection is way more than just a simple on or off switch. It's more like a Swiss Army knife, giving developers a whole toolkit of options to manage how their software gets used. This toolkit offers a few different flavors of protection. A developer might use a plain version for a simple app with basic encryption. Remote is the one we've been talking about with machine locking. In an office, network licensing might make sure only, say, 5 people can use the software at the same time. And for super secure tools, the license can be locked to a physical USB key.
You know those 30-day free trials you've used before? Yep, that's this exact same technology at work. That security envelope can be programmed with an expiration date or a counter that only lets you open it 10 times, giving you a chance to try before you buy. And it's not all about locking you down either. The best systems actually empower you. They can let you securely deactivate a license on your old laptop and then just seamlessly transfer it over to your new one. For maximum security or even for portability, developers can choose to lock the license to a physical USB drive. In that case, the drive itself literally becomes the key. The software will only run when that specific USB drive is plugged into the computer. Pretty cool. So, as you can see, this technology is powerful, it's complex, but it all really comes down to navigating one fundamental trade-off. It's this constant balancing act. On one side, you have the developer, who has a totally legitimate need to protect their creation and their business. And on the other side, you have the user, who, let's be honest, just wants a process that's simple and just works. The best protection systems are the ones that are strong enough to stop piracy, but so smooth that the honest user barely even notices they're there.